All right, let's just jump right in. When you think about it, the solar system is really our cosmic backyard. I mean, sure, in the grand scheme of the universe, it's this tiny, tiny little speck, but it's our speck. And what an incredible backyard it is. It is just packed with a wild diversity of different worlds.
And this, of course, is where it all begins. Home. Earth gives us this one-of-a-kind vantage point to look out at everything else. It's our baseline, the standard we measure everything against. But the moment you start looking around at our neighbors, things get, they get wonderfully weird and very, very different.
And that really leads us to the big question, the whole reason for this explainer. Why? Why are the planets so dramatically different? What forces, what processes shape them into these completely unique worlds that we see today? To answer that, we've got to go deep. I mean, literally. We have to start deep inside each planet because the secrets to their personalities, what makes them tick, it all starts at the core. And a huge piece of that puzzle is something called the dynamo effect.
So, what's the secret recipe for a planetary magnetic field? Well, turns out you need 3 key ingredients. First, a hot inner core to really get things cooking. Second, a churning liquid outer core that allows for convection. And third, the whole thing needs to be spinning. That rotation is what turns the planet into a gigantic electrical generator.
But here's the thing. This recipe does not produce the same result everywhere. Not even close. To really see how different the outcomes are, let's do something fun. Let's imagine the planets are all students in a big cosmic classroom, and they're each presenting their magnetic field homework. Okay, so first up to the front of the class is Venus, and its excuse is, let's just say it's a bit of a slow starter. See, Venus has the hot core, check. It's got the liquid convection, check, but it spins so incredibly slowly that it just can't get that dynamo going. So for Venus, zero magnetic field vibes. And that's a huge deal, because it means it's basically defenseless against the solar wind, this constant stream of particles blasting out from the sun. Then there's Earth, the star pupil of this assignment. Earth checks every single box and generates this powerful, beautiful magnetic field. And this is where we see just how critical that is. This field is our personal shield. It protects our atmosphere, it protects all life on the surface from all that nasty solar radiation.
Now, Mars has a much sadder story. It tells the class it used to have a magnetic field a long time ago, but because it's a smaller planet, its core cooled down faster, it solidified, and the dynamo just shut down billions of years ago. And without that shield, the sun slowly but surely stripped away most of its atmosphere, leaving behind the cold, thin world we see today.
And then you have the giants. Oh boy, Jupiter and Saturn are in a totally different league. The immense pressure inside them creates these cores of liquid metallic hydrogen, which is an amazing electrical conductor. The result? The most powerful magnetic fields in the entire solar system, by far. Uranus and Neptune, on the other hand, they're just plain weird. Their fields are kind of weak, they're lopsided, and they don't even line up with their rotation. They are definitely the oddballs in the back of the classroom.
But a planet's core, its invisible magnetic field, that's really only half the story. To get the full picture, to really see their personalities, we have to look at their surfaces, where all these internal differences are basically written in stone for everyone to see.
And wow, this chart really just lays it all out, doesn't it? I mean, look how wildly different the paths of these rocky planets have been. You've got Mercury, just an airless, cratered rock. Then Venus, a high-pressure oven with this crushing CO2 atmosphere. Then there's our home, our perfect little oasis. And finally Mars, a frozen desert with just the ghost of an atmosphere left. Let's just zoom in on Mercury and Venus for a second. Looking at them side by side like this, you are seeing 2 completely different life stories. On the left, you've basically got a planetary fossil, and on the right, a world that decided to wipe its own slate clean. So here's the key takeaway. When you see a surface like Mercury's just absolutely covered in impact craters, that's a huge clue. It's telling you that the surface is incredibly old and that not much has happened geologically to erase those scars. It's like a time capsule from the early, violent days of our solar system. Venus, on the other hand, barely has any craters, and this tells us its surface is geologically young. Something must have happened, and our best guess is that at some point in its past, massive volcanic eruptions just paved over the entire planet with fresh lava, erasing all the older features. It got a complete, planet-wide resurfacing.
And what's so incredibly exciting is that we are right on the cusp of understanding these worlds in so much more detail. The story of our solar system is not finished. In fact, it's still being written, and the next chapter is all about exploration.
I mean, just look at this timeline. Look at what's planned for the next few years. We're sending a rotorcraft, a literal drone called Dragonfly, to explore Saturn's moon Titan. Venus is about to get a whole fleet of visitors with Veritas and Vision and Da Vinci, all designed to peel back its secrets. And we are finally planning a dedicated mission to the mysterious Uranus system. And this really gets to the heart of it all. We're not just visiting these places to get cool photos. Each new mission, every single piece of data adds another piece to this giant puzzle of not just how our solar system formed, but how planetary systems everywhere are born and how they change over time. Which leaves us with one final fascinating question to think about. As we look out into the galaxy, a galaxy filled with billions of other solar systems, we have to wonder, which of these planetary personalities is the exception, and which one is the rule? Is a world like Earth the cosmic norm, or are we the strange ones, the exception in a universe filled with barren Mercuries, hellish Venuses, and frozen Marses? The only way we're ever going to find out is to keep exploring.